Okay, so today we're going to be dealing some more with position versus time plots, folks. Um, the biggest difference between today's lesson and the last lesson that we looked at is that now we're going to be looking at two objects going on at the same time. So here on this plot, you can see we're plotting the position versus the time, and then we've got two different cars. So we've got a blue car, that's car 1. And then we've got a red car, that's car 2. And again, we're plotting the position and the time. So the first question that I ask is which direction is each car moving? Well, if we look at car 1, we can see that as we go to the right, the line is moving upwards. And that means, again, that the slope is positive. So that means that the car is moving forwards. So car 1 is moving forwards. If we compare that to car 2, we can see that as we go to the right, the line is going downwards. That means that the slope is negative, so car 2 is moving backwards. So that's hopefully should be kind of a review. Let's just do one more review question here. Let's see if we can figure out if we can find some information about the cars from the graph here. What is the position of car 1 after 5 seconds? So I'm going to go down to my x-axis where we're measuring the time in seconds. I'm going to find 5, and I'll follow that up to the graph for car 1. Now car 1 is the blue one. So I'm going to go past this point all the way up to here. Okay, and then I'm going to follow it over to the x-axis. And I see the position is also 5. So I'm going to say 5 meters. And then when will car 2 reach the 4-meter position? Oh, whoops. Sorry about that. There's a little typo in there. So the next question is when will car 2 reach the 4-meter position? So I'm going to start at 4 meters, follow it over to the car 2 graph, and then I will follow that down to the time axis. If I go down, I can see that that's going to be a time of 0. So when will car 2 reach the 4-meter position? That's going to be at 0 seconds. So that's actually where car 2 starts. Okay, let's keep going. Which car is moving faster? To do that, we need to calculate how fast they're going using the slope. So we'll start with car 1, right? Remember the first step to do that is to draw the rise and the run on there. The rise looks like it's going to be 2 meters because it goes from 3 to 5. 5 minus 3 is 2. The run looks like it's going to be 2 seconds because it goes also from 3 to 5. 5 minus 3 is 2. Okay, and so then we take our rise divided by our run. So we're going to go 2 meters divided by 2 seconds. And that's going to equal 1 meter per second. All right, now we'll do the same thing for car 2. And do that over here. We can see that this goes down from 4 to 3. So this is going to be minus 1 meter. The run is going to be 2 seconds. Negative 1 meter over 2 seconds equals negative 0.5 meters per second. So which car is moving faster? Well, 1 is bigger than 0.5, so car 1 is moving faster. The sign really doesn't matter, so don't worry if it's negative or positive when we're comparing which car is going faster. We're looking at the number, not the sign. So, like for example, if this one was negative 2, even though negative 2 is technically a smaller number than positive 1, negative 2 would indicate that this car is going faster. It's just going in reverse. Okay, when will the two cars be at the same place? Well, we can tell that from the intersection here. So the first question is asking when, so we want to follow that down to the time, which is down here. We can see that that's in between 2 and 3, but probably a little bit closer to 3 than it is to 2. So I estimated this as about 2.6, maybe 2.7 seconds. Where will the two cars meet? Okay, so now we're going to follow it over to the y-axis. And again, in between 2 and 3, probably closer to 3 than it is to 2. So I also estimated this to be at 2.6 meters. If you get one where you have to estimate and you don't get the answer exactly, I'm not going to mark you down heavily for it. Or I'm not going to mark you down at all for it. As long as your answer is close, right? So just use your best estimation skills. Okay, let's go through one more example. So which direction is each swimmer moving? Well, we can see that for swimmer 1, as we move to the right, this graph is moving up. And same thing with swimmer 2, right? As we move to the right, this graph is also moving up. So which direction is each swimmer moving? Both swimmers are swimming forwards. What is the position of swimmer 2 after 3 seconds? So I'm going to go 3 seconds. I'm going to follow that up to swimmer 2. That's right here. And I'm going to follow that over to the position, which is 6. So it should be at 6 meters. When will swimmer 1 reach the 5-meter position? So I'm going to go from 5, follow it over to here, and then down here. And again, it looks like it's in between 2 and 3, maybe closer to 3 than it is to 2. I estimated this one to be at about 2.7 seconds, roughly. Which swimmer is swimming faster? Okay, so again, we're going to need to determine how fast each swimmer is swimming using the slope. So we'll start with swimmer 1. So I've drawn the rise here and the run here. Now just a reminder, I'm just picking 2 points on the graph. It doesn't matter which 2 points you pick. I'm trying to pick ones that are going to make it easy for me to figure out what the time is. Okay, so then what is my rise? Well, that looks like I'm going from 4 up to 7. So that looks like 3 meters. 7 minus 4 is 3. For my run, looks like I'm going from 2 to 4. 4 minus 2 is 2 seconds. So then I'm going to take rise divided by run. 3 meters over 2 meters. And that should equal 1.5 meters per second. So that's how fast swimmer 1's going. Let's do swimmer 2 next. So I've drawn on my rise and my run. Okay, so let's figure out what the rise is. It's going from 3 to 4. That looks like it's just going up by 1 meter. Going from 0 to 1 looks like it's going over 1 second. 1 meter over 1 second equals 1 meter per second. So it looks like swimmer 1 is definitely the one that's moving faster. Okay, when will the 2 swimmers be at the same place? So again, we're going to circle the intersection where the 2 graphs cross each other. So the first question is, when will they be at the same place? So we're looking for a time here. We're going to follow it down to this axis. Looks like the time is going to be 4. So 4 seconds. Where will the 2 swimmers meet? Okay, so then we're going to follow it over to the y-axis. Looks like that's going to be at 7 meters. Okay, and so then we've got some practice problems. We're doing the exact same thing. Give those a try. If you have any questions, as always, let me know.